So in these first couple of problems, we're going to be graphing rational functions. A rational function is simply a function that has a polynomial in the denominator. And so in order to do that, what we're going to do is first we're going to find the x-intercepts, and they are found at values that make the numerator equal 0. We'll find our vertical asymptote or asymptotes. Those are x values that make the denominator equal 0. And then we'll plug in a few points to see what's going on from there. So as we look here for x-intercepts, we want to look for values that make 1 equal to 0. Well, 1 is never equal to 0, so there are no x-intercepts. So our graph will never, ever cross the x-axis. And we'll use that fact a little later on. Vertical asymptotes are found at values that make the denominator equal 0. So sometimes we would have to factor this, nothing to factor here. So we want x plus 2 to equal 0, and so we subtract 2 from both sides and we get x equals negative 2. Also, we can easily see that negative 2 makes this denominator equal 0. So we have a vertical asymptote at x equals negative 2. So we can draw a vertical asymptote there. And now what we're going to do is just going to pick a x value over here and an x value to the right of our asymptote to see what happens on either side of that asymptote. And so what we can do, let's pick negative 4 for our x value, and then we'll figure out what the y value is. So if we put negative 4 in here, that's 1 over negative 4 plus 2. Well, that's 1 over negative 2. So when x is negative 4, the y value is negative 1/2. And then we'll pick something to the right. Usually 0 is an easy one to pick, so when we put 0 in there, we get 0 plus 2, and that's equal to 1/2. And so when x is 0, we get y equals 1/2, and that's actually enough for us to tell what these graphs look like. So we know that there are no x-intercepts, so this graph will never cross the x-axis, so the graph definitely has to stay below the x-axis. This is a vertical asymptote, and then the x-axis in this case ends up being a horizontal asymptote because it can't cross the x-axis and it has to keep coming out this way as our x values get larger. And then the same idea over here. Here's our vertical asymptote. We know it starts up here because if it started down here, it would have to cross the x-axis to get to this point, and we know there are no x-intercepts. So that was a little shady on that graph. But it comes down, goes through our point, and has a horizontal asymptote. So that's a basic sketch. It is a bit messy with this program here. Our next one is similar. So we're going to find the x-intercepts, find the vertical asymptotes, and then find some things in between the asymptotes to help us figure out what happens with the graph. First thing we're going to do here, which we do with a lot of problems, is we're going to factor this, and this factors to be an x plus 3 and x minus 1. And that's our denominator. And so for our x-intercepts, that's what the values that make the numerator equal 0. X equals negative 1 makes the numerator equal 0, so we know that is an x-intercept. And then in the denominator, the values that make the denominator equal 0 for our vertical asymptotes are x equals negative 3 and x equals positive 1. So we find those two, we go ahead and sketch those in there. So here's where x equals negative 3. Here's where x is equal to 1. It's this vertical line. And then we can choose values in each section. So I actually use negative 4 again. And so putting negative 4 in, we can use either fraction. Let me rewrite this. And we can erase this here. So whichever fraction is easier to use. These two are both the same, so we can plug negative 4 in either one. I'm going to plug it in this second one, so negative 4 plus 1 over -4 plus 3 times -4 minus 1. And that gives us a -3 on top. This is a -1 times a -5. Gives us a +5. So when x is -4, y is -3/5. So that's about right there. Next one over here, we're going to, let's plug in 0, because 0 is usually easy to plug in. So that's 0 plus 1. And plugging in 0 in the numerator here, denominator, you'll have 3 times -1, which is -3. So you get -1/3. So when x is 0, our y value is -1/3. And then we'll plug in 2. I'm just going to think through this. So looking up here, 2 plus 1 is 3. 2 plus 3 is 5. And 2 minus 1 is 1. So we get 3/5 when we multiply that out. So 2 and 3/5. And this is actually all we need to graph it. Same idea here. We know it doesn't cross the x-axis because the only x-intercept is at -1. So it has to go through this point and come down. That wasn't a very good graph. This should be getting closer and closer to the x-axis. Over here, our clue here is this point right here. These 2 points, it has to cross the x-axis here and has to go through this point. So this has to come down this way, because if it came up this way, it wouldn't, after it hit the x-axis, it wouldn't get to this point. So it comes down, goes through the x-axis, goes through the point we have there, and then we can draw that part. And then same idea as here, but we have to be up and go through our point because it doesn't cross the x-axis again. And so that's a sketch of our graph. This should not cross the x-axis. I know it looks like it does, but it does not. The real function does not cross the x-axis there. So those are the first 2 questions.